Okay, here's our problem set. And we're going to read the direction up on top. This is a small little direction, but it's going to help us with solving the problem. It says use the RDW process to solve. RDW means read, draw, write. All right, so problem right here is our tape diagrams might help us out a lot with this, okay? So we're going to read the problem. We're going to need to figure out what we need to do, and then we're going to solve the problem, okay? So we're going to start off with number 1. Sue ran 9/10 of a mile on Monday and 7/10 mile on Tuesday, period, stop. Okay, so I can see that on Monday she ran this far, and on Tuesday she ran that far. Okay. How many miles does Sue run in the 2 days? So I got to figure out, what do I need, what is my operation? Is it an addition or subtraction? And the way I look at it is if I draw a tape diagram, if I say, well, if this here is Monday, okay, she ran 9/10 of a mile, right? And then the next day with Tuesday, she ran 7/10 of a mile, right? On Tuesday. I need to know how much she ran altogether. The only obvious thing I've got here is to say, well, I need to add those up, right? I need to add up those two fractions to figure out how many miles she ran in 2 days. So that's what I'm going to do. I'm going to take these. I'm going to say, now I'm going to write my workout. I'm going to say 9/10 plus 7/10. What does that equal? I got same unit, so I'm good. And then 9 plus 7 is 16. Great. She ran 16/10. Now I notice 16/10 is not quite right. I need that's a fraction greater than 1, so I need to make this into a mixed number, okay? I could do this one of two ways. I could do it by a number bond, or I can do it with our trick, okay? I can say, well, how many times does 10 fit into 16 without going over? And that would be 1/10, because 2 10s would be 20. So 10 would fit into 16 one time. And then, so if I do that, so over here on the side, I'm going to show you what I'm doing in my head. I'm saying 10 fits into 16 one time. And then I'm subtracting, I'm finding, and how it fits in one time, how much is left over. See that 6? My remainder 6? That's what I'm going to put right here, 6. And then my units stay the same. So my answer here is 1 6/10. Okay? 1 6/10. And I can reduce that 6/10 further. So, but 1 6/10 is fine. Now I need to write out my answer in a complete sentence. Say, Sue ran 1 mile and 6/10 on in 2 days. Gotta give myself a label here. Miles. There you go. Miles in 2 days. Period. Great. Hopefully that worked out for you. Good. All right. Let's move on to the next. Here we go. Mr. Salazar. Wow, that's a cool name. Cut his son's birthday cake into 8 equal pieces. Period. Stop. Oh man, you know how many birthday parties I've been to? A lot. And I know that every time we go to a birthday party and there's cake, we have to cut it into equal pieces. All right? Or some people cut them in not equal pieces. But Mr. Salazar, Mrs. Salazar, and the birthday boy each ate 1 piece of cake. What fraction of the cake was left? Okay, I can do that. So we're going to do our tape diagram of a model, okay? So let's do that. Let's draw this cake here. Here's the cake. Now, I'm going to cut this cake into 8 equal pieces. And I like to use rectangular cakes, okay, instead of the circular cake. Because circles can get tough to do, okay? So I need to cut this in 8 equal pieces. And there's a few different ways I can do this. I have to think about arrays. I got to think of 8 equal pieces, all right? I could do 1 row of 8. I could just cut them down, just horizontally here like this. Or I could do 2 rows of 4, right? Because 2 times 4 is 8. That's how I'm going to do it. Because I know if I got a cake that looked like this, I wouldn't make long slices. What I would make are, nice square slices. It's easier to eat. So I'd cut it down the middle here. I'd cut those halves in half and make fourths there. Then I'd cut it right down and make little square pieces like that. that make sense? Yeah. Okay, so this is my whole cake. That's one right there. That's my whole cake. And then, how many pieces did they eat? Salazar and Mrs. Salazar, Mr. Salazar, Mrs. Salazar, and the birthday boy each ate one cake. So they ate all of these cakes, these pieces of cake. Okay? So I'm going to say these pieces were eaten. And these were not. I can see how many are left over, right? Can you say this is what fraction of the cake was left? This part right here was left. I can see that 5/8 of the cake was left, can't you? Yeah. So that's my answer. But if I were going to do that, I'm going to say 1 whole cake minus 3/8. Okay, and what does that equal? Well, we got to change that 1 into a fraction, right? We got to change this 1 into 8/8. The whole cake is 8/8. And I'm going to subtract this 3/8, the amount that was eaten. And then that's going to give me 8 minus 3. There's my 5/8 that I was looking for. 5/8 of the cake is left over. Does that make sense? I hope so. So now, what do I got? I'm going to say there was 5/8 of the cake left over. Period. Neat. Okay, let's check out the next one. Maria spent 4/7 of her money on a book and saved the rest. Period. Stop. Okay, so apparently she has some money and she spent 4/7 of it. Okay, it's a really odd way to talk about money, but okay, all of her money was 7/7. She spent 4/7 of it. What fraction of her money did Maria save? Okay, so I got to figure that out. So this is what I'm going to do. I'm going to draw a rectangle here and show how much she spent. Okay, she spent 4/7 of her money, right? And I'm going to write that down here. She spent that much. Okay, now she has some money left over, doesn't she? We just don't know how much. This is how much she saved. That's my question mark, right? And I'm going to label this little part of my tape diagram as saved. Okay, so that's how much she spent. That's how much she saved. And up here is how much she had total to start with. That was my whole thing. All right, 1. Okay, good. So now what I need to figure out is, what am I doing here to figure out my problem here? And is it addition or subtraction? So if I've got 1, what am I going to do with that 4/7 to figure out this? And the answer here is subtraction. So I need to take my 1 and I need to subtract the money she spent, which is 4/7 of her money. But I don't know about you, but I need to change this 1 into a number that's got 7 as a denominator, because I need to be subtracting the same units. So I'm just going to change this 1 to 7/7. See that? Then I'm going to drop this down here and then subtract it. So I got 7 minus 4 equals 3/7, just like that. Okay? That's the amount she saved. So Maria saved 3/7 of her money. Period. Okay, good job. And we're on to the back. All right, so Mrs. Jones had 1 4/8 pizzas left at her party. After giving some to Gary, she had 7/8 pizza left. What fraction of the pizza did she give to Gary? Okay, so you probably know when you go to a pizza party or even a birthday party, there's always pizza left over. But when those pizzas come out of the boxes, they're cut into slices, right? Apparently, I can see that the unit here is 8ths. These pizzas were cut into 8 pieces apiece, all right? So what I want to do is talk about how much she had left over at the party, okay? So she had a total, draw one big rectangle, she had a total of 1 4/8 left over, okay? And then she gave some to Gary, okay? She gave 7/8 to Gary. So I'm going to make a rectangle here and say 7/8. After giving some to Gary, she had 7/8 left. Oh, that's it. After giving some to Gary, we don't know how much she gave to Gary. She had 7/8 left. So 7/8 is what she has left. And this is the amount she gave to Gary, which we don't know. It's some. So what fraction of pizza did she give to Gary? Okay. So discuss, is this a subtraction or an addition problem? She has 1 4/8 pizza left. She gave some to Gary. Now she has 7/8 left. This to me reads subtraction problem all the way. So I'm going to take the total amount she had, 1 4/8, and then I'm going to subtract the amount that she's got left over to figure out how much she gave to Gary, right? Okay, this is how much she had. I'm going to subtract the amount she has left to figure out how much she gave to Gary. Now I got this mixed number. I'm going to change this mixed number back to a fraction greater than 1. And I'm hoping that you can remember. I know our class is practiced this a few times. So what we do here is we start in our denominator. Let me zoom in on that so we can show you, okay? And we need to multiply it by the whole number, right? We're going to go 8 times 1, and we get 8, right? So in our head we have 8. And then we have to add that numerator. So 8 times 1 is 8, plus 4 is 12. And that is my new number on top. And this 8 stays the same down here. Okay, that's the same unit, so 12/8. Now I can subtract 7/8. See how I got the same units on the bottom? Okay, so 12 minus 7. That equals to 5/8. That's how much Gary got, okay? Does that make sense? So, Mrs., let me write it down here. Let me zoom back out again. Mrs. Jones gave Gary 5/8 pizza. Sounds on. Great. Okay, let's check out the next one. Teachers are kind at any time. If you want to stop this, do them on your own or whatnot, feel free. A baker had 2 pans of cornbread, period, stop. Usually I have cornbread with my chili. It's good. So a baker had 2 pans of cornbread, 2 pans. I'm thinking rectangular pans, okay. He served 1 1/4 pans. What fraction of pan was left? Okay. So, well, that's how much he served. All right, he served 1 1/4 pans. Okay, so you know what I'm going to do? I'm going to draw this out in pictures. I'm not going to do a tape diagram here because I think a tape diagram makes it kind of confusing, okay? So if he served that, how much does he have left? So I'm going to draw my 2 pans of cornbread. Okay, 1 pan, 2 pans of cornbread. Good. Now I need to figure out how many. What did he cut? He cut this in each of them in the fourths, didn't he? Yeah, he cut them each into fourths. So I'm going to cut this one into fourths and this one into fourths. Okay. So he served 1 full pan and 1/4 of another. So he served all of this. That's 4/4, and then another 1/4 out of this pan. That's how much he served. Does that make sense? So he served all the shaded. Served 1 1/4, right? 1 pan and 1/4 of a pan. How much does he have left? How many fourths do you see left? You see 3/4, right? Well, that's our answer. So we got to show this in mathematical terms here, okay? So what I'm going to do here is show that he's got, let's see, he's got 2 pans, right? So let's write that down. He's got 2 pans, right? Now what I need to do is show that he served, so he gave away 1 1/4. Okay? Good. Now I want you to understand that we're dealing with fourths. So we got to change everything into fourths with the denominator of 4th. Okay? So this is what we're going to do. I need to change this 2 into a number with fourths. Okay? So what that looks like is this. You see my 2 pans? Let's count how many fourths are in 2 pans. Ready? Count with me. 1, 2, 3, 4, 5, 6, 7, 8. Okay, there are 8 fourths in 2 pans total, right? That's how much he started with. Do you agree? Teachers, you can pause and discuss that if you'd like. And then what he did was he subtracted 1 pan and 1/4. Well, if I do this, 4 times 1 is 4, plus 1 is 5, 5/4. He really served 5/4, and I'm going to show you. Let's count the amount that he served that's shaded. 1, 2, 3, 4, 5. You see how he served 5/4 there? So then when I subtract that, did I put halves down here for some reason? Man, 8/4. Sorry about that. All right, so when I subtract that, watch this. 8 minus 5 is 3, and the fourths remain the same. He has 3/4 left over, and check out our picture. How many does he have left? Yeah, 3/4. So if he has 2 pans, he cut them into fourths. He served 1 pan and 1/4. He has 3 left over. So he has 3/4 left over. So 3/4 of a pan is left over. Good. All right, last one. Okay. Marius combined 4/8 gallon of lemonade, 3/8 gallon of cranberry juice, and 6/8 gallons of soda water to make punch for a party. How many gallons of punch did he make in all? Okay. When I say how many did he make in all, it means he combined them. You see that? He put them all together. So what kind of a problem is this? Addition or subtraction? This is a flat-out addition problem, isn't it? Yeah. What we need to do is take my lemonade. Here's my lemonade, which was 4/8 gallon. And that's my lemonade. Lemonade. And I'm going to combine that with 3/8 gallon of cranberry juice. Let's write down cran. And then 6/8 gallons of soda water. Ooh, it's going to be bubbly. Okay, 6/8 gallon right there. So I'm going to put that of soda. Okay? All right, it says how much punch did it make in all? Did it make in all? So I have to add these up. So that's what I'm going to do. I'm going to say 4/8 plus 3/8 plus 6/8. Cool. All the same denominators are all the same units. I'm good. Okay? So I'm just going to add across the top. 4 plus 3 is 7, plus 6 is 13. 13/8. But I don't like leaving fractions with that look, that fractions are greater than 1. It looks like it's top heavy. So we're going to fix that. So how do you remember how to do this? I say 8 goes into 13 one full time without going over, right? Because 2/8 would be 16. That's past 13. So if 8 fits into 13 one time, how many is left over? Which is basically what's the difference between 13 and 8? And the answer is 5. And then, of course, my 8 stays the same. So there's my answer. 1 5/8 gallon of punch. So Marius, let me write it down here. Made 1 5/8 gallons of punch. Period. Okay, I hope that you had fun with that today. And, I changed some things up here the way I thought you could see them better, especially number 5, okay? 2 pans of cornbread. There's my 2 pans. He served 1 1/4 pans. I just cut them both in the 1/4. I got to figure out what my units are, and then that's what I'm using. And I can see it just by drawing a picture, okay? All right, guys, that was a good lesson today. Tomorrow we'll be back, and we'll continue with our addition, subtraction, and fractions. I'm getting a little bit more difficult stuff, but I think you're going to enjoy it. All right, we'll see you tomorrow, guys.